Welcome to Calculus in the AM. I'm just recording. Just in case somebody joins in late. Hope somebody does. Number sets, though. What's the number set that we use that includes all the numbers that you guys are familiar with? Real numbers. Yeah. So, sometimes people will use this, the set of real numbers. Real numbers. Within the real numbers, you could get into two different sets. And you could break these down further. Sometimes you'll see a Q, go a line through it. We call those the rationals and then the irrationals. Q with a line over it, meaning the ones that aren't rational, irrational. Now, the rational numbers. Think of examples of an irrational if you can, and rational numbers. So, when you hear rational, you might think ratio. Ming, we haven't heard anything from you today. An example of a rational number. Sorry? Not? Okay. About? 4. Okay. All rational numbers can be presented as fractions. How could 4 be? Is that truly a rational number? Sure, 4 out of 1, 8 out of 2, and so on, right? 16 out of 4. Okay. So 4 is a rational number. So is negative 2/3. So is, well, 0.25. Negative 5, like basically all of those numbers could be put into fractions. That's the set of rational numbers. What are irrational numbers? They're numbers that can't be put into fractions. What are some examples? Matt, do you have any examples? Pi is a perfect example. Okay. And where you come up with them a lot too is pi. Also radicals that aren't like square root of 49 is 7, so that's not irrational. But square root of 2, square root of 3, square root of 5, those ones, the decimal expansion goes forever without repetition, meaning it can't be put in fraction. I'll add one in here. You've probably seen it on your calculator. You ever see there's an ln button and an e to the x button on it? We'll be looking at e later on in the course, so I thought I'd mention it now. Is 2.718 and blah, 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 it goes on and on. It's sort of like pi. It comes up in some formulas and stuff like that. Now, you're familiar, I'm assuming, with this kind of notation. A set of numbers between 1, this equal sign means includes 1, and up to 4, but because it doesn't have that little equal sign underneath it, it doesn't include 4, right? You guys totally, this is an assumption here. Okay. So, how do we do this with interval notation? The same set, instead of the greater than, less than stuff, we'll say it starts at 1, goes to 4. I'm going to add on something to here. So what it starts at and what it goes to.
Can Blue come to the guidance area, please? Rochelle Hoosty, Tori Lara, Taylor Fink, Wyatt Ewan, and Rocky, please. Thank you.
Rocky like the ball. Okay, it's cool. Right? Now, I included a square on the 1 and a round bracket on the 4. Sometimes these will look like an ordered pair, x comma y, but you'll know from context whether or not it is or isn't. This square bracket means the number 1 is included. Basically just like less than equal to, right? So the number is included. And here the number 4 is not included. That's why it's given a round bracket. Always go from least to greatest, smallest to largest, 1 to 4. Don't go 4 to 1. That's our norm. Now, these answers are for the questions that I assign you later on, so don't worry about that. There's not much to this, but we'll just see something else about sets. Okay? So we can describe all numbers larger than 3, less than 10, or less than or equal to 10 using several kinds of notation. And we'll take a look at these notations. Second page. So, round bracket, meaning the 3 is not included, larger than 3, but doesn't include 3, right? So that's why I use a round bracket here. That's why you use a less than sign there without an equals. This 10 belongs to the set, so equal to 10, less than or equal to 10, right? 10 is the max number, it doesn't exceed it. Whereas this number, 3.00001 is included, but 3 is not. There really is no starting point because you could always find a number. If I said 5 zeros in between the 3 decimal, I could add 6 zeros the next time and make it even closer to 3. Okay? Same information. You should be able to go back and forth between these two. Now, set and interval notation. I'm not too hung up on using this all the time. But curly brackets and stuff like that, if you see them, you know that that's a set. We might just say between 3 and 10 like that. Like this, though, more often. But what is this fancy epsilon? It's like an E. What does that mean? Element of. And it really means belongs to. The variable x belongs to the set of numbers starting at 3, not including 3, and going up to 10. That's what this means. This implies the same thing, okay? So that's an element of, if you want to add that, belongs to. X is an element of 3 to 10. Now, the old notation you guys have used too, you usually did it this way, or sometimes, did you guys use a line instead? It's not a big deal if you use a colon or a line. I'm fine with those. Now, what do these represent on a number line? And these are the symbols we're going to use. A and B also represent the set and inequality notation. I'm saying use this notation as well. For given the interval, this means 1 starts at 1 and includes 1. So I'm going to just grab, in my case, where's my 1? Starts at 1 and includes 1. I'm putting mine above because I'm going to put the other one below the number line. And goes up to 4 but does not include 4. Goes up to 4. So this is how I do it on a number line. And oh. Now does that make sense for A? I think because advisory ends at 9:50, I would assume that. Because then we're right back on schedule.
Back on schedule.
Yeah. So we got 18 minutes to put in. This guy's killing me. It's boring. Now, does this make sense to you? Nope. Which part? Oh, it does? Okay, different notes. Now this one here, it's a sideways 8 beam. Infinity, right? Meaning there's no starting point. It goes to the left forever. So that means I've got no real starting point on the left, but it goes up to and does not include -2. Just so I'm going to fasten this to it. And there we go. There she be. -2 all the way down. Does that make some sense? Now, set an inequality notation. X such that How would we do this one with greater than, less than stuff? Now, where am I getting this from? Here, right, above D.
Would somebody from maintenance please come to the office? Thank you.
Always go from least to greatest. Starts at 1, goes to 4. Here's the way I advise you to do this. Starts at 1, goes to 4, and X values are in between this, right? Then you think, does it include 1? Yes, it does, close dot or else square bracket, right? So I'll say less than, equal to, and the 4 is just less than, and the bracket, and there you go. Now, infinity and negative infinity aren't numbers, so we don't even have to put them on our greater than, less than. This is why I want to show this one. X such that, in one statement, greater or less than, what would we say? X compared to negative 2. It doesn't include, so there's no equal portion, but what do we put, less or greater? Less than. Okay. We do have this understanding? Good? Okay. Real quickly, can you guys come up with the 2 sets? I'll give you guys a second here to do that. Go ahead. We'll shake them up in a second. And then we'll shake things out. But I know I'm going immediately fast. Okay, we're back on. What kind of brackets do I need to indicate numbers between negative 1 and 1, but includes those endpoints? Squares. Now, this is called a closed set, by the way, or closed interval, because it is it has a definite start and a definite end point. Okay. It starts at negative 1, it ends at negative 1. Now this other one has no definite starting point and no definite end point. As a matter of fact, because we have to put something in the second thing, though, what would we put? Infinity. Infinity is not a number, it just means increases without end. This is definitely an open interval, okay? Meaning has no end. No start in this case as well. As long as you have one round bracket, you're guaranteed it's an open interval. It could have square bracket, comma, round bracket. That's still open, even though it has a definite starting point. Okay. Now the last little bits here, and union. I think you might have seen this in the Foundations 20. Did you guys union? You guys talk union of sets? No. Not that you recall? Nope. Okay then. That's why I'm saying I think. I didn't know. Use interval notation to represent each set of numbers. Now, as soon as you see this symbol, it sort of looks like an unfinished A. That's and. If you want to just toss this under here, just say and. And a mathematical and means kind of and or. And the word or we use a U kind of, without a tail on it though. Okay, so this means X belongs to the numbers you could choose from to use in an equation or something like that. Anything between negative 6 and 5, not including the number negative 6, and, so that's why and, the numbers negative 2 through 8. Now do you see that those numbers, if you visualize them real quickly, I'll just say, well, I'll keep them as scratch mark. So negative 6 to 5, dot there. and negative 2 to 8. Now, here's what we've got to consider. What is in the first set and the second set? It starts at negative 2. Does it include negative 2? Yes, it does, because this would include negative 2, right? And it ends at 5, right? So the actual set would be from there to 5. Voila. So, I'm only putting the number line there as a thinking step. This set is the same as negative 2 to 5 inclusive, including brackets, right?
I got a question.
Sure.
For negative 2, isn't it supposed to be including it?
I'm sorry?
For negative 2 and comma p, it's supposed to be including negative, like on the number line on the second. Get an open dot.
Have an open? Oh, yeah, you're right, it's closed. That wouldn't have changed a thing though, but you're right. And the 8 is not supposed to be included.
Yeah.
Thank you.
Yeah.
Exactly, yep. Keep correcting my errors, I make a lot. Now, negative 3, or negative infinity to 3. So, I'll use a different color for this one. I'm thinking 3 is not included, so 3. Everything below that, right? Or, starting at 2 and going up to 20. Well, I'm going to just put 20 down here. You'll get the idea. Just because it's off the map, that's fine. Now, or means something else. It means it doesn't have to belong to both, does it? If I said and, it would only be this small portion, right? But since I said or, it basically means from negative infinity all the way up to 20, not included.
Would the following students please come see
So I'm going to put that up.
Wood in
Same
guidance,
as.
Ashton Levin Stark, Kenny Shiva, Amandeep Singh Brar, Minghu Se, and Mary.
Now, sometimes those sets can't be joined up into one neat set like I did in green. Okay? If there was no overlap in the middle, I would still, if this, for example, the number right here was a 1, there's no overlap, right? And there's no way you could rewrite that interval any differently, okay? Now, and I realize first day, I'm leaving you with some questions to try because of introduction kind of stuff. But mentally solve this inequality. X squared is greater than 9. Mental, for sure. Well, when is x squared equal to 9 is usually the way you think of it. At 3 or negative 3. So 3 and negative 3 are kind of the magic numbers that you're kind of thinking of, right? Now, is it the numbers that are greater than, give me an example if you're thinking of 3 is equal to 9, right? Like 3 squared. So is it numbers larger than 3 or smaller than 3 that satisfy this? Pardon? Have to be smaller. Well, I'm thinking just right around the neighborhood of 3, like meaning 4 or 2. Which one works in this equation? Because there are, I can't say you're wrong, because there are smaller numbers that do work. But, what are we thinking here? X squared is greater than 9. So would 4 squared be greater than 9? Yep. Whereas 2 squared wouldn't. Okay. So, mentally I'm thinking 3 starting, not including, end up. So, I know that negative 3 are my points. these numbers, right, will work. 4, 5, 6 squared, but not 3 itself. What about negative 3? Would have to be negative 4, negative 5, right? Oh, sorry. So it'll be the numbers less than negative 3, and that's why I was careful when you said something earlier, Ava. There are numbers smaller than 3, but there aren't numbers like 0 that work for this. And use interval notation. How would I use interval notation then to write down what we just put? Negative 4, negative 5, positive 4, positive 5. Well, the first set on the left, I'd say negative infinity up to negative 3, round bracket. Then the other set, I'm leaving a space here because I'm going to put and or, and you guys will help me decide, starting at 3 and going up. So, and or. Do the numbers have to belong to both sets? That would be and. No, it's an or. It's either like negative 4, negative 5, or it's a number like 4 and 5. So we use a union, united. Oh, there we are. And I'm going to stop the recording.